everyone, I am Avleen Malhi from Aalto University, and in this presentation we are going to discuss about OMI ODF wrapper and how to use it. OMI ODF wrapper is a piece of code that generates OMI ODF message to publish data or request data. It allows to combine data from different sources or systems with different or same protocol into single ODF structure for publishing. In real world, in single application, there might be multiple sensors supporting different protocols. The details of each protocol should be hidden in a way that when two systems communicate, their details should be encapsulated. For example, the requesting entity for data from different sensors need not to understand the underlying protocol of each sensor. OMI ODF wrapper hides this complexity and sends only data for the requesting entity in the form of OMI message. The wrapper can be written in any preferred language of the developer, for instance, Shell script, Java, Python, C, etc. In order to demonstrate the capability of wrapper, we have considered the use case scenario of smart home. This smart home consists of data publisher, which publishes its sensor data to OMI reference implementation using OMI write request using wrapper. The data consumer can request any data using OMI messaging standard based on its need. In this use case scenario, smart home publishes its data to reference implementation. Here, smart home is equipped with air handling unit with different sensors installed in its subunits which have proprietary protocol. For instance, bedroom and living room are equipped with sensors measuring temperature and humidity of corresponding room. OMI ODF wrapper reads and combines these sensor values into single ODF structure and send it to reference implementation using OMI writing messaging interface. To read or write the published data, developer can use web client to test the system. Data consumer, for example, air handling unit, maintenance company, in this case, could be interested in sensors data for developing predictive maintenance methods and therefore can subscribe the object of interests from reference implementation. The example of OMI wrapper for sending AHU sensor data to reference implementation is shown in this slide. The example of OMI wrapper for creating ODF structure, which is used in previous slide, is shown here. The sensor data that has been sent by OMI ODF wrapper to reference implementation is depicted here. For example, we can check humidity and temperature of bedroom. This picture depicts the web client of the reference implementation. The web client is capable of automatically creating the OMI message for which the user is interested. The user has to select the object of interest for which OMI request needs to be created, and user also needs to select the OMI operation and its corresponding parameters. The OMI message is automatically generated in OMI request area as shown in the figure. The user requests the data by clicking Send button. The response is received in OMI response area for the callback address which user provided while creating the message. This slide presents all steps the user has to go through for deploying an OMI node. Step 1 includes deployment of reference implementation. Step 2 includes development of wrapper for publishing data as discussed earlier. Step 3 includes sending OMI write request to reference implementation to create or update data periodically using wrapper. Finally, web client can be used to test OMI ODF functionalities. It is also worth mentioning that other systems can also read or subscribe published data by sending read or subscription request. For further information, please check the provided links.